Hi everybody, welcome back. Well, as you can see, I've made some progress on this. I have everything put back together, and even though I got a few scratches on my paint here, I was able to clean off the transformer, as you can see, and get it looking a lot better. I'll zoom in a little bit. It looks pretty good. Cleaned up well. There is a tiny bit of pitting on the other side that you can see underneath the paint, but really, all in all, that isn't too bad. Pretty happy with how it turned out. The rest of the chassis cleaned up. The back of it, as you can see, or maybe can't see, still has a bit of corroded spots or, surface rust. I tried to get that polished off as much as possible, but there's some that's just where the paint has been eaten away. And really, without making it look uglier, you really can't do this, paint it, unless you want to, redo the screening and all that. I can't do that. I still have a little bit of cleanup to do on the heatsink, which that'll clean right off. It should. The new capacitors went in really well. I'm pretty happy with them, the way they turned out. And everything's plugged back in. So I think we're ready to do a power-up test. It's all wired. I did go over my work after I put this together, and I only so far found one wiring mistake, and that was on the star ground here. I forgot to connect the two ground wires for the main power supply there, the big one. And showing you that, let's see. If you look here, these center taps, the gray and the black wire, that would be this wire and this wire, on the board they don't show it correctly on the schematic, but what they're doing is where it plugs onto the back of the board where these go together, those are combined, and you can see they go to chassis ground. They tie together all right there and go to number 4. So I had to bring those out, and I made a new star ground because the old one was, instead of copper, it was made of steel, and it was really rusty. You can see how badly rusted it is. So I decided to get rid of that, and I made this one up here just out of 5 terminal lugs, and I soldered them and tied them all together, and you can see where it kind of makes a good connection. So everything is star grounded, which that's desirable. If you can do that, that's always the best way to go. Eliminate any kind of ground loops or anything like that. So everything's together. Let's get the meter out, and let me get a couple things set up, and I'll be right back. Okay, I have the buzzy transformer turned on, our isolation transformer. Let's connect to ground, and I'm just going to start with this positive lead on one side. So there's this, even though it has one transformer, each channel has its own set of windings. So there's a set of windings, you have the blue windings and the purple windings, and that's for left channel and right channel. So you have a left positive and negative and a right channel positive and negative, and they're mirror, identical copies of one another. So we're going to start this left one here, the positive. Okay, I have the smallest current limiting bulb selected over there, and that's only, I think, a 40 watt bulb. So I don't think we're going to get past the soft start circuit on this, and that bulb is it should be full brightness when it turns on, and then it'll kind of dim down a little bit. But I don't think we're ever going to come out of the soft start relay. It's never going to come in, and I don't think we're going to get the protect relay either. But we'll see. So let's turn it on. I am now looking again at the red lead there on that channel, so this should be a positive voltage. And it's really bright, but it is dimming down. This is good. And you can see the voltage is going up, as I would expect. And this is supposed to be, I think, plus and minus 50 volts or something like that. What was it? let's see, 55 volts at full power. It'll be 55 volts. So you're only halfway there. But you can see how that dimmed down. And I want that to be like that. If something's going to go wrong, that bulb's going to limit the current enough that it's not going to hurt anything. Okay, our negative, it's the same. That's good. So we have a good positive and negative rail on this channel. Here's the negative, and it's the same. That's good. If I go over to this one, it's good. So we know we have our, at least our main power rails. So now let's look at our regulated supplies, which are probably not going to be regulating very much by now because, again, I don't have, these are, I think these are 33 volts or something like that, and we only have 28. I don't know if I'm going to have anything here, but let's see. 33 volts. And let's go to the negative 33 regulated. It's good. So our regulated supplies are working. We have a good power supply. Okay, I'm now switched to the 110 watt bulb right here. And I'm going to go back to this positive lead here, and it should get close to that 50 volts somewhere, 55 volts. Let's go. That was the soft start. And there goes the protect relay. So it came out of protect, and we also got the soft start relay to pull in. And you can see we're about 10 volts shy of where we need to be, and that's the light bulb limiting it. But there should be enough power there to make these transistors all start conducting pretty well. So if there was any problems on one side or the other, you would see a drop in the voltage, and I'm not seeing that anywhere. So it looks good. All right, I think we can see if there's any kind of DC. We shouldn't have any DC on the speaker terminals because the protect relay pulled in and was happy. So let's look at that. What's our offset? Well, that's good. 3 millivolts. Okay, I'll buy that. How about this one? 3 millivolts. It's jumping around a little bit. Holy moly, that's good. Okay, you all know I just can't wait. So I have this connected to the signal generator, to the scope, and to the PA81. And I'm still on the middle current limit bulb. I don't know if you could see that out there or not. But let's just see. I'm going to feed 100 millivolts into it. And I have the levels turned the whole way up. Let's see what it does. And I'm getting about a half a watt per channel. And lo and behold, we have a decent looking waveform. And our meters are both reading. At least they're reading something. So I would say that this amplifier is working. Okay, we're now switched over to the 300 watt bulb. And so far, it looks pretty good. And we really didn't get a whole lot more power. I didn't think we would. So that looks good. But I think I can increase the input a little bit. So let's go up to 200 millivolts. And 300 millivolts, and that's getting us just under 5 watts per channel. And let's see if I can change the scale on my scope. We're still getting a really good waveform, and we're lighting up that 300 watt bulb now a little bit. But bottom line is, and I'm going to turn this back down, everything's working. So right about now, you're probably asking, Tony, what are you doing? And I guess I would say I'm getting ready to adjust the bias for this amplifier. And of course, our old friend the audiophile showed up, which he's actually being useful this time, as you can see. So what's this all about? Well, we'll find out in a minute here. Is this necessary, what I'm doing? No. But, hey, this is a hobby. It's fun. And sometimes you just like to use the audiophile, which is what I'm doing right now. Okay. Look at that. So will it work? All right. If you look, they want you to pull the red lead, which is your B+ voltage going out to the main amplifier, and they want you to connect your milliamp meter between the red wire and the terminal there. That's coming straight off of the rectifiers and the capacitor bank. The problem is they use, well, let me give you a better view here. They use one of these little spade terminals, but it's not the normal width that you would buy at a hardware store. It's a little bit narrower, and I don't have any of those. So I thought I would just make one. That works perfectly. And I'm going to make another one for this channel because I do have 2 meters. I'm going to hook them both up together. Why am I doing this? Because it's fun. If you can't have fun when you're doing a hobby, then it's not a hobby, right? So I'm just kind of eyeballing this, and I'm just filing it down to a narrower width so it'll fit in there. And then I'm going to crimp it onto a piece of wire so we can hook our meter to it. And that's all there is to it. And again, I could probably just shove my meter probe in there and be done with it. But what fun is there in that, you know? Plus, the next time I need to do one of these, I will have this test tool. Yes, this is considered a piece of test equipment. And I won't have to do this again, and it'll make things much easier and faster. So, if you plan on doing this kind of stuff, it's always worth taking the time to, to get the proper test equipment or test jig or wire or connector or whatever. We do this a lot when you do radio alignment, especially like ham radio and stuff like that. And shortwave and things like that, because invariably they always have in their instructions some special kind of setup that you have to, I got to take a little more off of that, some special setup that you have to make in order to be able to align it, some connector with resistors and capacitors or whatever, and you connect it to the antenna jack or something like that. And again, making a neat version of one of those is just going to help you in the future, because if you ever have to work on your receiver again, or if you're going to work on another one down the line, then that's going to really help. So, and yeah, little pieces fell off of there, but that's okay. All right. Oh my goodness. Got to go a little bit more. I think this one I can just, because I don't have to take a whole lot. Are you bored yet watching all this? I'm not. I'm having fun. And I have the audio file. Okay, I don't know if I recorded what I recorded or didn't record, but Here we are crimping this on now. You know it's crimped enough when your knuckles crack like that. Just, you know, just so you know. It's kind of my built-in torque wrench. Okay. Now, I've got this, and I've got this. Let's put our tools away. Thank you, Mr. Audiophile. That was quite useful of you. I'll put you back in here. And let's hook up our meters. Okay. My camera just played games on me again. I hit twice now. I hit the record and it came on and back off. So Lord knows what I missed. So I'm going to repeat the whole schmeal. There are two different procedures. One is using test equipment. So you use a distortion meter, a 40 kilohertz test tone coming out of your signal generator. You're going to drive that signal to about 15 volts RMS into a 8 ohm load, dummy load. And then you're going to adjust the bias pots for minimum distortion. That's the best way to do it if you have that kind of test equipment, which most of you do not. The other way is just set it and forget it. So you basically use that little connector that I made with those two little spade terminals, and you put your milliamp meter in series with the B plus line of each channel, turn the amplifier on, let it settle a little bit, and then you just adjust the two pots up here on the top till you get about 100 milliamps. And I'm gonna adjust it a little bit cold, because usually that's a worst case scenario, whatever they have you set, when they tell you to set it to a certain current like that. So I'm going to go a little bit lower. I went to 80, it's at about 82, 84, something like that. Now maybe later on what we'll do is we'll play with some of these settings, and when we're doing the actual testing of the amplifier, we'll go through and we'll do the 40 kilohertz and the 15 volts, and kind of see if we can get it any better than it is. But my guess is it's not going to be any better. It's going to pretty much be okay where it is, but I could be wrong. So that's it. This is adjusted. It's ready to go, and I can put it back together, and we're ready to actually do some physical testing of the amplifier. Okay, so here's the little test leads that we made, and just like I do with all the other special test equipment, when I do that, I go up here, and back in here I actually have a whole bunch of prefab test things that I made for test, for different pieces of gear. And that way, next time I need it, I have it. Okay, there it is. It looks really good. Now the covers, I still have to send out to get them powder coated and everything. I just have not had the time. Work has been brutal lately. I've had very little time to work on the bench, and it's only going to get worse for the next month, because I have employees going on vacation, and I'm down one guy, and I have a bunch of work coming up. It's just the perfect storm at work. So you may see me, you may not, on and off. Sometimes I'll have time and sometimes I won't. But this looks good. Let's turn it on. I always like when the lights dim when you turn these things on, even with soft start. Okay, so it's all set. Let's connect the PA81, and I have to still connect a test signal. Hold on. Okay, we've got our 1 kilohertz in there, and we want to see, according to this, you want 29.7 volts, which is going to give you 110 watts into 8 ohms. So what we're looking for is somewhere around 29 to 30 volts, something like that. And we'll just see what kind of distortion we get. Again, this is just a basic test. And I'm getting off scale here already, and that's 24.5. And if we go over to the distortion meter, 0.36, that's really good. Remember, the distortion meter kind of bottoms out around 0.01 somewhere. And go one more click. There's 27.6. That's about 100 watts. And I'm still sitting at 0.042. And there's 30.7. That's going a little bit high. And still 0.022. So actually dropped a little bit. So it's good. Amplifier is good. And the heat sinks, it warmed them up a wee little bit. So now they're above room temperature. But not bad. So there's our first test, and let's see where it clips, where our clipping is. I'm going to have to go a little bit higher voltage here. And let's just see how far we can go. Right about there is clipping. I can see it, and that's 30, about 31 volts. We'll call that about 31 where it starts to clip. So at 1 kilohertz clipping, where we start to hard clip, we're at about 120 watts, which is where we would expect it because this is a 110 watt rated amplifier. So it's performing well, and I'm using all the original transistors. The only semiconductors that got replaced in this were some of the transistors in the power supply and a few of the diodes, but the power amplifier, the preamp, all that stuff, all original transistors, and they're working just fine. Okay, let's do our frequency sweep from, where am I going, from 10 hertz up to, what, 25 kilohertz, something like that. Make sure it doesn't breathe. We want to make sure that everything looks good. Not bad. That's pretty flat. And again, we're not checking distortion, but we're just checking to see if there's, if the amplitude drops with frequency. We want it to stay flat because we're putting a flat input to it. Okay, that's good. So now I'm going to come out of sweep, and let's just try some higher frequencies now. Okay, I'm going to drive this at about 15 volts, like they say in the service manual. We're not going to go all the way to 40 kilohertz yet. Let's try 10 kilohertz. And just see, I don't want to see any ringing or anything like that. Okay. That's a beautiful waveform at 10 kilohertz. That looks good. And of course, that's kind of because the test equipment, that's really low, but I think there's probably more distortion than that, but who knows. All right, let's go to 20 kilohertz. I just want to see if we have any kind of ringing or anything, and then we'll go to the square wave. All right, there's 20 kilohertz. And it's staying pretty flat. I mean, we're down a little bit amplitude-wise, not much, but a wee little bit. I would expect that. Okay. And unfortunately, I don't know if this Keithley can measure distortion at 40 kilohertz, but we'll try it and see what it can do. Let's see if I can even... Okay, so there's 40 kilohertz. And as you can see, when you get to that frequency, it's not going to be able to measure that. You can see I can't measure distortion at 40 kilohertz, so that test is not possible with my test equipment. The Keithley 2015 is a good piece of test equipment, and if you're within the range that it was designed for, in that audio range, it's excellent. But it really doesn't like frequencies below about 100 hertz, and it doesn't like frequencies above about 10 to 15 kilohertz. It says it has a range between 20 and 20 some kilohertz, but really when you get to those extremes, it gets kind of unreliable. So I try to only test distortion in that range. Let's look at our square wave. I'm going to go back to a 1 kilohertz. I'm going to switch to a square wave, and I'm going to drop my amplitude just a little bit. Well, I'll leave it where it is right now. And there's your 1 kilohertz. Let me bring this in a little bit. You can see there is no ringing or anything whatsoever, no oscillation, nothing. You can see a little bit of that, of the slew rate on this. Let me go way out. Let's see if we can take a look at it a little more. There's your rise time there. We could probably measure that, but I can tell you right now it's not bad. It's pretty good. And do you notice both channels are tracking right on top of one another, which is great. Perfect. Okay, feeling the heat sink. Well, it's warm, as you would expect. Let's see what we got here. 111 degrees Fahrenheit, 44 C. So that is not bad. I would call that respectable for running this thing this hard. Everything else is good. Transformer is cool, capacitors, none of that should be warm. The power supply is ice cold. Not ice cold, but very respectably cool. Other than a couple little power resistors down here that are running warm, but they're big resistors. I can feel a little bit of heat coming off of that, not much. So yeah, I think we have a winner here. Now we could also use the Instech MDO2204 and we could do the frequency analysis, but I don't think it's going to be necessary. Just from experience, I can tell this it's fine. It's perfect. Okay, since I don't have anywhere to clip my mic, I'm going to set it right there and hopefully you can all hear it. So I have a better faceplate than the one that came with it. It's not perfect, but it is a much nicer example than the one that was on it. This one just has splatter and it's gouged up, and some stoner with his black fingernail polish went and kind of put, you can see, just tried to cover over all the gouges and things on it. Like across the top you can kind of see how bad it is. And it's got some corrosion here, which probably will clean off. It's got all kinds of overspray, and the anodization is really faded. So this one looks a lot nicer. I'm going to use it. And again, has a little bit of wear on the lettering, but not bad. The only problem is it's missing all of its accoutrements. So what I'm going to have to do is transplant the ones from here onto here. And in order to do that, I'm going to have to deal with this glue, which probably won't be as big of a deal as you might think. So let me get started on that, and I'll be back. Okay, so I think I'm all in frame. So I have 3 different products that I'm trying. Well, not this. This is last, if necessary. And I'm trying just plain old acetone. This stuff called Goo Gone, which is a citrus-based, and it just smells citrusy. It's not, harsh on your nose or anything. And then last but not least would be, this will work, but it's hard on plastics. You really don't want to put this on the plastic if you don't have to. And the acetone I used for this little switch bezel here, or switch gland, whatever you want to call it. Worked pretty well, but it was a little bit fussy. So then I went to the Goo Gone with this, which also seems to work, but I think the acetone actually worked a little bit better. But you can see, you put this stuff on and just let it soak for a while, and it just pops right off. This one here is still a little bit tight. It has to go for a little bit longer. It's about ready. There we go. And you kind of just let it work. You don't want to force any of this because you don't want the plastic to crack. And we'll just work our way around. And if I destroy this, you will get to see that right on camera. Huh? Won't that be wonderful? Hopefully not. And this doesn't, whatever this glue is, it's pretty harsh stuff, but it's still pliable. Like if I push into this with my finger, it's still a little bit soft. It hasn't totally hardened over the years, like some of that glue does. I think this is the same kind of stuff they use to glue capacitors down to the circuit boards. And when it totally dries, it'll deteriorate and it'll get really hard. But sometimes it doesn't, and it'll stay kind of pliable like this stuff did, which gives it a little bit of flex. And when you get some kind of a chemical under it like this, you can see how nicely it cleaned right off. And I don't know how much I stayed in frame. I'm not looking at the viewfinder as I'm doing this, but hopefully you can see. So I have two down. I don't have all three of these, but two things down. Now I got to take these off, and I have to take this little LED bezel out. I might have another one of those that I could use if this one is too far gone. This plastic on here will get really brittle, and it'll break if you look at it funny sometimes. Hopefully this one's not like that, and we can get it out. But these all seem to be in good condition, so they should be able to be transplanted into the, well, newer bezel, the better conditioned bezel, I should say. Okay, so now we have to do this. And the idea is you don't want to get anything on that plexiglass, because this is not glass, this is plexiglass, and it will discolor and fog very badly if you get stuff on it. So I'm probably going to try the acetone on this. I'm just going to do a couple of layers of it, because this can just soak around the edge like so, and then I won't have to drip it onto the glass. I just don't want to get it on the glass. Okay. I'm going to let that work for a little bit. It evaporates very quickly. You'll see this real time. You know, I'm not speeding the camera up. Now this Goo Gone does not evaporate. It just kind of stays on there. It's oily, and you have to clean it off. So, and it doesn't really seem to do a much better job than the acetone. So I think I'm going to just keep trying to use the acetone on this stuff. We'll try it. There we go. Just as simple as that. See how easy that works? This Sony ZV-1 camera, I noticed something about it. I love it. It takes beautiful images. It does a nice job, but it overheats very quickly. It's a camera, and they advertise it as something for vloggers and so forth, for video. But if you do a long clip on this thing, I don't think that's going to work. If you try to do a long clip with this, the camera just shuts itself off for no reason whatsoever. It just turns off, and then you have to boot it back up. It just did that right now, so I don't know what I cut off, but it does that. All right, let me see if I have a replacement for this so I don't have to break this. Okay, so as it turns out, I actually have some metal ones. Am I grossing you guys out with my thumb? Sorry about that. It's not as bad as it looks. It just kind of smeared around on there, but some people really don't like that. I apologize. I'll clean my hand off here in a second. But here's a metal one, and it's the same size. So we lucked out. Them are city hands, Mr. Hooper. I'm talking about working for a living. I'm talking about sharking. Okay, that's my best Clint impersonation. By the way, the original Jaws is one of my favorite movies. I love it. I like Jaws. I like Raiders of the Lost Ark. There's a couple of them that really, really liked. You know, the one-liners in those movies and so forth, and the scenery on it, just totally cool. So let's see if this is going to fit. Look at that. All right. Perfect. Every now and then, even a blind squirrel finds an acorn, don't they? Is that what they say? So this is actually nicer than the one that was on it, if I do say so myself. Look at that. Even complete with my fingerprints. All right. And I have one of these here fancy, what's it called? Gallium kryptonite, whatever it is. I don't know. All you electronical people with this stuff remembers what they're called. LEDs or LEDs. Some people like to call them LEDs. There. If I make a dirigible out of these, would that be a Led Zeppelin? Oh, dad joke. Okay, the deed is done. And I used this Star Bond, and this stuff is no joke. You just put a couple drops, and your fingers are instantly bonded together. Yeah. So, it's all done. And the only thing is I still have to clean these bezels a little bit more, because I still have some of that overspray paint stuff on there, and that's going to have to be scraped off. But I'll wait till it dries better, and this is ready to go on. Nice. Okay, it's all together, and it looks pretty good, at least from this angle, without taking the camera off the mount. That's as low as I can get with the camera. But let's turn off this little background light, and let's see what it looks like. Hey, not bad. How about that? You can see that shuts off when the protect circuit comes in. So that means it's ready to go. Nice. I think we're ready to try some music. Okay, what kind of music can I annoy you all with today? Let's try something that is near and dear to my heart because it has the word in it. X-Ray Vision by Slink. I don't even know what it is. Let's play it. You can even adjust the jiggliness of the meters with these buttons. Let's go for maximum jiggle. that rattled my chest. I think we all get the point here. All right. Okay, there's my little microphones. It's the first time I recorded using both microphones, one on each speaker, so we'll see how it turns out. And I may have overdriven the input. It didn't look like it from the meters, the VU meters, but I'm experimenting with all this. So, man, does this thing have bass. I mean, and again, I'm just driving this from the computer. I'm just using my buffer amplifier, driving it straight into here with no tone controls, no nothing. And I mean, the bass was actually, like I said, it was rattling my chest. I mean, this thing's crazy. So, and it's dead silent. There's no hiss, no hum, nothing. So this thing's great. So I did get to go out this week to the powder coaters, and I was able to deliver the covers, so they're going to get done. And he said he thought he had enough of that that bronze color paint, the matching paint for the cover. So this cover is going to match the cover of one of the preamps. The other preamp is original. I didn't repaint it because it was in not terrible shape. It wasn't perfect, but it was okay. I'm not going to spend all the money on getting that one done. So when that comes in, we'll have that cover on. Now, the next video I'm going to do is going to be fun. I'm going to have a lot of fun with it. I'm not going to tell you what I'm going to do. Some of you may be able to guess, but when we come back, it should be an interesting video. Maybe a little bit longer one to get through the material that I want to cover. And when we're all done, we'll actually get to see this and the preamp stacked on top of one another with its new covers. And that'll wrap this whole series up. So until then, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you again very soon. Hopefully, work contingent, we'll see how work goes. But we'll see you soon. Take care, everybody. Bye-bye.